Hello friends, today I am now going to discuss a very important formula of 1D quantum harmonic oscillator, and I am going to discuss a problem of that 1D quantum harmonic oscillator that has come into the exam of Joint Entrance Screening Test India 2018. So let's discuss that topic and that question also. So what was that question? You all know that Hamiltonian of the harmonic oscillator is what? P square by 2m. It was given that Hamiltonian of the harmonic oscillator was given P square by 2m plus half m omega square x square. Here P cap and x cap means operator of momentum, operator of position operator. Momentum operator, position operator. Okay. So what it was given in the question, it was given that it is perturbed with potential Vx equals lambda x to the power 4. That 1D quantum harmonic oscillator potential was perturbed with the potential Vx equals lambda x to the power 4. And some matrix element of x square in the terms of its expectation value in the ground states were also given. In the ground state, it was also information was given that in the ground state expectation of x square is given as c, and 0 x square 2 it was given as root 2c, etc. etc. Some important information was given. Another important information was given that 1 x square 1 it was 3c. Another important information it was given that was 1 x square 3 root 6c. Now it was also mentioned in that question, and you should also know that here K10 be a normalized eigenstate of that Hamiltonian, unperturbed Hamiltonian corresponding to that quantum harmonic oscillator, and that has energy eigenvalue what? That is energy eigenvalue E0 equals h cut omega into n plus half. It was given in that question. Now it was given that suppose del E0 and del E1, del E0 and del E1, it denote the energy correction to the ground state and the first excited state. It was energy correction in the ground state and it is energy correction in the first excited state. Okay. So it was asked that ratio of energy correction to the first excited state to ground state. So how we can solve this problem? I am telling you with a very important formula. We can solve it within 2 minutes. Within very few lines we can solve it. So first formula which you should know, that in 1D harmonic oscillator, quantum harmonic oscillator, what is the expectation value of x to the power 4? This should you know. In 1D quantum harmonic oscillator, expectation value of x to the power 4 was given in such a way that h cut square by 4m square omega square 6n square plus 6n plus 3. I mean, I should write in proper way that ket n Brian x to the power 4 ket n. This can be written as h cut square. The result is 4m square omega square 6n square plus 6n plus 3. Now in the question what it is asked? In the question it was asked that energy correction to the first excited state divided by, in the question it was asked that energy correction to the first excited state delta E1 divided by energy correction to the ground state, it was asked. So energy correction means what? That you have unperturbed Hamiltonian. You have unperturbed Hamiltonian, that is known as P square by 2m plus half m omega square x square. You have unperturbed Hamiltonian, and that is perturbed by perturbation potential lambda x to the power 4. That means whenever we are going to calculate the energy correction, we have to take expectation of this perturbed potential. We have to take expectation of this perturbed potential. Okay, that's the main thing. That's the key thing here. So whenever it was asked that delta I means what? Delta I means correction in the first excited state. That means expectation of lambda x to the power 4 perturbed potential, or in simple way it can be written as ket 1 lambda x to the power 4 ket 1 bra 1 lambda x to the power 4 ket 1. So now we are using that formula. What that formula was? H cut square by 4m omega. So we can write it lambda h cut square by 4 m square omega square. Okay, 6n square plus 6n plus 3. But here n is what? Here n equals 1. So 6 into 1 square plus 6 into 1 plus 3. So we can write the energy correction in the first excited state as delta E1 as lambda h cut square by 4 m square omega square, 6 into 1 square, that is 6, plus 6 into 1 plus 6 plus 3. So we can give it a name, that is it is a constant value, so we can write it as C1 into 15. Now expectation value of energy correction, energy correction in the ground state. Sorry, energy correction in the ground state means what? Expectation value of that perturbed potential lambda x to the power 4 in ground state. So we can write it in what way? We can write that lambda in the ground state means 0 x to the power 4. So here it will be that constant lambda x to the power lambda h cut square by 4m square omega square, that formula we are using, into 6 into 0 square plus 6 into 0 plus 3. So if we denote this constant as C1, we have denoted already this constant as C1, so delta E0 we are getting 6 into 0 plus 6 into 0 square plus 6 into 0 plus 3, that is 3C1. So what is the ratio of that energy correction? The ratio of that energy correction will be delta E1 by delta 0, C1 into 15 divided by C1 into 3. So answer will be 5. But the most important thing, what we learned from this question? We learned from this question that whenever perturbation term is what? In such a way that C1 into x to the power 4, and the system will be what? System is 1D quantum harmonic oscillator. So what formula we should use? 1D quantum harmonic oscillator. And if it is asked to find the energy correction, in the nth state, so which formula should be used? The formula that will be used here, that x to the power 4 expectation, that is ket bra n x to the power 4 ket n, it can be written as, in 1D quantum harmonic oscillator, lambda h cut square by 4m square omega square plus 6n square plus 6n plus 3. So that is the today's learning from this question, and it was a question from JEST-2018, a quantum mechanical problem. So thank you for today. Thank you all for patiently watching my video. Bye.